you get directly what is your answer. Here, there are many things to solve, no? Because you need really to apply your assumption and then do some tangent lines, at least two tangent lines, and then the two tangent lines will narrow down into the things that you are going to solve, no? But not really direct, no? So this is an indirect way, no? Indirect way. So, but this is a way of solving slope and deflection of a beam. Okay, so we have an example last Monday. We have a uniformly distributed load in the entire span of a simple beam, and what we do there is that we just look for the slope at the support, no? And by doing that, we do tangent lines between the two, no? The two support. So A and B, and to determine the angle is just determine the area of moment area diagram given by the term AI between those 2 points that you are concerned. Okay, so I will start. Sa our this one is just a continuation of what we have last Monday. In fact, we will kickboard in the problem that we solved already. Okay, so this is it. Okay, so last Monday actually, if I still remember, uh, we try to solve for the slope at A, no? At A. So we have a uniformly distributed load over a span of 12 meters. This is a simple beam, okay? And before that, we try to do the, what we call this, elastic curve or the depicted structure, no? So because the load is downward, so there's also a downward deflection, no? So we know that the slope at A and B are equal, no? Because of the, what we call this, symmetry of loading, okay? And EI is constant, even though the load is symmetrical, but your constant is not, is your EI is not constant all throughout, meaning that your cross section is varying, no, it becoming very small, just like a branch of a tree, no, starting from big one until at the end it will become too small, no. So okay, so if you are going to bend that, so the one with a stiffer, the one, the area which has more stiffness deflects less compared to one with less stiffness. Okay, so anyway, we are just looking for the angle at A, at A. Doing tangent lines at A and B and determine the slope. This is what we call tangent line, the slope for the two tangent lines at A and B. So the subscript here tells us that we are going to determine the area for A and B. But this slope is double the slope of A. So we equate that equals to 2PA. So if we can find the area of the moment diagram here divided by EI, and we just divide it by 2, that is already the slope at A. Okay? So we do the moment diagram and then we determine the area. This is just a parabola. The area of the parabola is 2/3 base times height. So that's why 2/3 is here. The base is 12 meters and the height is 360 as the maximum moment. So the area there is 12 and 360 times 2/3. And of course, EI will always appear, no? Because that is in the theorem. No? So that becomes 2880 EI. No? That is the slope of A to B. But we are just looking for theta A. So by this equation, that theta AB is equals to 2 theta A. So we just get directly theta A. And is this correct? Okay. So first we try it using equation. Okay, the equation is equal to this. Theta A equals to WL cube over 24 EI. So we plot, we substitute the value for W, value for L, So we have 1440 EI, because I input negative 20, so that is negative. And they are the same. So that means that's correct. Now, for this afternoon's problem, we have only actually less time, no, but I can solve it. So I will continue. So I will say problem 2. Say determine ang ayaman din na siya sa slope di ay we will solve problem outside slope, no? So determine the mid-span deflection of problem of previous problem. Okay, so we have here the previous problem. Okay, I will get this. Okay, I will get that, and then I put that here. Okay, put that there. Together. Okay, that's the previous problem. I'll put load here 20. That's 20 kilonewtons per meter. Okay, and then on the bottom, I will put maybe 12 meters. Okay, and then I will put here y needs span. Okay, that's the y needs span. I will make this as a subscript, but the y needs span is this one. This is the y needs span. So this is it. The y at mid span. Okay, that's the y at mid span. Okay, that's the y at mid span. From here up to that. Okay. Now I can still do the tangent line. Copy. And then paste it. Still here. This is what we call tangent at A because I call that A and this one as B. B. Okay. B. Now actually I'm just looking for this, but if I'm going I will make this as my point, another point. I will make this as C. I will make the midspan as point C. That one as point C. And if I'm going to draw a tangent line at point C, is that this will become like this. Okay. That is, I draw tangent line directly at this point. So because this is the lowest point, so no wonder that you have a horizontal distance. Okay. So we are only looking for this, but if you extend this one, if you extend this line actually up to here, you can call this as, okay, this distance here as what we call T T T E T E C. So that is tangential deviation from A to C. A to C. So meaning, if you will be solving for TCA, you are going to use the secant theorem, no? This one, the tangential deviation is that one. Okay, you use that one, no? This is taken from our previous lecture, no? That the tangential division between lines EB with respect to D is equal to the area of the MEI diagram EB multiplied by the distance of the situated area moment from B. Now, since we are talking about AC, so I will just as well copy this one and convert it there, put it there. Okay, so you have that one. Now, I am talking about A to C, so I will just change this to A to C. And then, of course, this one will become AC only. And distance moment from C. Okay. Okay, so this one will become TEC, and this one is uh, TEC with respect to B to C. We're talking on the C here, not B. B is there. We want only this distance to that. We're talking about the deviation of the two tangent lines at that point. Okay, since this is TA and this is C, so we're talking about distance, not the slope. Kung slope lang, area lang, hindi tayo mag-talk about with respect. So this one is EC with respect to C. Okay, with respect to C. Okay, multiply by XC. XC. Okay, that's it. So that means that if this is the moment diagram, this is the moment diagram of the problem. This is the moment diagram. I will copy this. If that is the moment diagram, home copy. Here. We have problem. Why? Because this is A and this is B. This is B here and C is here. C. So we need to half this. We need to half this because we need only this area actually. From this point up to that point, no. We only need half of this, no. Only this one is needed actually. So because it is area easy, and then if we can find the centroid here, the centroid is somewhere here. The centroid is somewhere here. So that's the centroid. So we need this distance actually. We need this distance. And then we call this distance from there to there as X sub C. Muna siya gitawag ng X sub C. So we need this area of the moment diagram, although the moment here is determined as 320, 320. Maximum 320 here and that's 320, 360, 360. Okay. We need only one half, no? In the area of the parabola, that is 2/3 the same height. This is 12 meters, no? This is 12 meters. And this point here is C, no? That is C. That is C. This point here is C. Okay? We can determine, but determining this moment arm is difficult. So we need to change strategy. We need to change strategy. Okay, so we will make what we call the moment diagram that is uniformly distributed load and concentrated load about B. So we need to change the strategy. I will just say here, change strategy. Strategy. Why we change the strategy? Because for that reason that it will be hard to determine, or it will be not straightforward to determine the value of X sub C. The area of the subdivision is simple. That's 2/3, 12 times 360. This is 1/2. You just divide it by 2. No? That is the answer. But determining X sub C, this distance from the centroid up to point C, because that is what we mean here, is difficult. So I will not do that. No? So first is I am going to make a diagram like this. So with the load that is with the distance of 12 meters, 12. Okay, the distance of 12 meters, this is A, and this is basically 12 meters, and this is C, and this is B. load is 20 kilonewton per meter. No? So basically, there are two loads to consider. Okay. First is the I will say the load. Load. We will consider this load. Okay. And maybe if I am going to okay, I will fill that with a pattern. Maybe I will use this pattern. Okay, that's close. Okay. I know that ang one niya is 20. 20 is going down. 20 kN per meter. Okay. So, because of this 20 kilonewton meter, there is also a reaction. No? Reaction. We will include the reaction. Okay, the reaction here. Going there. Okay. And I will make maybe format. Maybe I will make that into color black and probably bigger. Okay, so I will copy that. So because on the other side there's also a reaction because this is also a support. Okay, so that's there. Okay, remove it little. Okay. Then with the 20 kilonewton per meter, so I am sure that this one is 60 kilonewton, while the other is also 60 ba? 20 times 12? 20 times 12. 20 times 12. Oh, to 40 ay, sa'yo po. Okay, this is 120. Okay, so basically, okay. So I can make my diagram one by one, no, one by one. What do you mean by one by one? No, you are not going to take the moment diagram as equal to this, but it will be broken into a triangle and spandrel of a parabola. Okay, how does it look like? It will become like this. Home, copy, paste. Okay, I will make here. Okay, that is my line. Basically, I'm going to make a diagram, but the diagram here is not like that. I will call this as a one. So still, this is my A, and then this is C, and this is B. Actually, if you are going to consider this two load, this 120 about B, so make this as your cantilever point, no? So meaning that if you make this as a cantilever beam here, so this one is a uniformly distributed load at the end the cantilever beam. Okay, so its diagram, this force could cause the beam to go up, no? It will be good as an effect to this. I will copy that again here, copy paste. So I'm just going to do that here, no? That is 120. That's 120 kilonewton. Okay. This 120 kilonewton force is enough to bend your one here like this. Okay, like that, no? That's the deflection, but I do not want that to roll out, so I'll just make that little small. Okay, no, don't leave, no, not. Maybe this one will be just like that, no? So the moment diagram of that will be equal to this. Okay, so it will be equal to this. Moment diagram is like this. Okay, it's like that. Okay, and the moment here is 120 times 12. So here, this is at B, moment is 120 because it's 12 meters away from the 120. That becomes 120 times 12. This is 1440 kilonewton meter. But we need only what we call the moment here. Moment here. No? We want the moment here. actually, if I'm going to copy this, copy and paste. Uh, I need only the moment somewhere at C here. I need only that moment. I will change the color of that into like that. Really. Okay. So I want only the one here. So this is the midpoint. So one half of 140 is this one is 720 kilonewton meter. Why I need only this red figure? Because of our equation EC, area in EC, no? So MEC, so this 720 times 6 meters divided by 2, that is the area of the red. No? The red is basically just the same as the blue one. No? It's the same as the blue one. Okay. Ano siya. No? So, because you need only AC. No? You only measure up to this point, up to that, up to here. Okay. But this moment is basically the one caused by this. The other one is due to this. Due to this uniformly distributed load. So what if that uniformly distributed load is acting here? What do you think is okay? So it will cause the beam to bend down. No, it will become to bend down like this. Okay, that's okay. Okay. This will be the bending of your beam. Okay, then I will change that one to this. Okay, that one. And the load is downward, no? Downward. So, because it will go like this. That is just caused by this. Uh, so, meaning, akong gibuwag ang effect sa duha ka load sa 20 og sa reaction. So, dinhi, yun ako'y E, ako'y C, ako'y D. Okay? So, if I'm going to determine the moment here, at B, that is 20 times 12 times 6. No? So, the moment here, no, if I'm going to do that, the moment will become like this. It will become like this. That's the moment. The moment diagram. Moment diagram. Okay. And then again, I'm going to insert another shape in terms of this. Okay, that is a second degree line actually. No? So I will check again, line. So, bali, the moment at B, here at B, is the moment at B, this is A. A na siya. A. Then here is B. We'll see. Naman natong kuan. Yung tao na tuloy. Muna siyang B. So, ang moment din sa B, moment niya is equal to the load here, 20 kNm multiplied by 12. So, that is 20 times 12. 20 times 12. Then, times its moment arm, which is 1/2 of 12. So, times 6 na siya. So, here, you have negative 1440. Negative because it is opposite to the other moment, 1440 kNm. So, if I want to determine the moment at the midspan at C, So there is again moment here. Din sa C. But moment is not that much, not as much as that. So if you want to determine the moment at C, it's not like this nga linear nga unsa ni sa 1440 na siya ang tunga dia. Mao na siya ang moment. So 1440 divided by 2 mo na moment sa C. Kini siya kay curve man siya kay second order naman siya, second degree line naman siya. So kung tungaon nimo siya, dili man siya 720 kay distance 720 man na siya. But I know that that one is negative. That's negative because of this kind of deflection. So moment there, just sum up moment at C. So you have 20 times 6, no? 20 times 6. That's 120. Then times the moment arm of 3 times 3. So here you have negative 360 pm. Okay. So if you are going to determine the distance here, xc from this point up to here, for a triangle, if this is 6, so it should be 1/3 base times height. So this is 2 meters. Okay, it's not at the middle, but it's somewhere here, no? Somewhere here. So whatever the length of this, if this is 6 meters, you divide that by 3. That is where the tawag na niya, the centroid of the red shape is, no? So na siya diya, din dapit yang centroid. Okay. Now, sa dinhi noon po, sa isa, dili nimo maingon nga 2 meters na po. Ngano man, lain naman ni siya. So, ang iyang centroid na niya, na siya di doon. Okay. So, for that, ang centroid na niya, kung second degree line na siya, it should be over n plus 2. So that is, if n here is 2 because this is a second degree, so that is 1/4 of the base. So if the base is 6, so xc here is equals to 6 divided by 4. So 4 divided by 6, how much is 4 divided by 6? 6 divided by 4, that's 1.5 meters. 1.5 meters. Okay. Kaya nga naman, ako explain ha, kung ingon ani gani ang imong kuan, out na siya sa kuan na. Explanation na nako siya. Kung ingon ani gani ang imong shape, niya kini siya gitawag nato na siya o kana to B. B ni siya nga length. Ang iyang x ana niya from the other side to the other side is equals to B divided by 2. Okay? How about kung dili ingon ana? Kung ingon ani siya, B na siya. Niya, triangle siya. Okay, triangle siya. Okay, mo na ang B. So, kung compute nimo ang x gikan din sa kuan, sa bigger area, ang x ana niya is equals to b divided by 3. Now, kung dili ko na second order, kaya siya, ang n ani niya nga kuan, nga curve, n is equals to 0. Kini siya, ang n noon ani niya, basta mag-slope na gali na siya, line gani, implied, n equals to 1. How about yung ani? Sa ko saan ako nagputuan na muna ni. Okay, katang-tama ko ni siya ang B niya din. Ang B, si Silong. Ang B. So, computer na to ang X. Ang X, ano niya? Kung ang N lang niya, N equals to 2, yun mo na siyang B divided by 4. Okay? So, ang iyang figure ano niya is like this. Miss yung mathematics actually ka na. Okay? So, pangalin natin yung na. Okay. So, yung na n equals to 4. So, it follows nga in general, ang figure dahil nga ingon ani na kay line Nya, nada yung kay curve. Kay curve mo na pagbago lang tani isa. Sabi ko. Di ba man? So, tupian na to. Space. Okay. Wala siya. In general, kung bini siya, so ang x ano niya, x is over in plus 2. Kung ang ini mo is equal to m at ang ganito, n equals to m. Okay. So here, the m here is 2, so that means m plus 2 is 4, so the base is 6 from here up to c, so that will be 6 divided by 4 because it is a second degree curve, so that's why you have a 1.5. And for this one, this is a triangle with straight line, so n of this one is 1. So if this is n plus 1 is 3, this is it. N plus 1 is 3, so whatever the length here, EC, which is equals to 6, you divide that by 3. So the distance from this point up to this point is equals to 2 meters. So thus it is easy to solve. So meaning that if you are going to multiply P E C is equals to the moment of area, you have two moments to take care. No? One is positive. Positive area of AB is 1/2 of 720 and 6. Okay, I will say 1/2. Then the base is 6. Then the height is 720. 720. That is the area. But it does not only say area because here, do na pa man tayo multiply by XC. Okay? Of course, I will put EI here divided by EI. And then, later na ng EI. No? So, times XC na yan, XC. The XC for this particular red line is 2. That's 2. Now, I use positive, no, because of the curve that's going up due to the action of the vertical reaction. It has also a positive diagram. No? We are only taking care of the red one. Okay. So, XC is 2 meters. So, then divided by EI. Okay. Then, we have also for the bottom, we have to add, but this is negative, so that is negative. And then the area of this one is not 1/2, but 1/3. No? 1/3. So, 1/2, apply mo ng 1/2 kung triangle. Kung ano na gani, ang area nila, let us say the area is equal to base times 1/2 base times height. Kini sa may area niya, area is just equal to base times height. Okay? So, it's base times height. Okay. Kini siya sa may area ni n equals to 2. Area is equal to 1/3. Okay, 1/3 base times height. So in general, area is equal to 1 over n plus 1 dx. Okay. So that's why for this one, n equals to 1. So you have 1/2. But for n equals to 2, just like this one, this is a second degree curve already. This one is minus 1/3 na siya, 1/3. The base is still 6 meters and the height is 360. But we consider negative already here. No? Pwede mo natin i-plus ni siya. Plus, kinidi mo minus 360. Minus 360. Pero, di na natin manaon. Hindi na lang. I-minus na lang natin siya. Now, it does not only mean area, no? area lang sa AC, A to C. It also needs X sub C, distance from C, because that is what is our formula is to the say XC. So, multiplied pa rin siya by 1.5. And of course, this is over EI. Okay. So, we can compute the TEC actually. That is the TEC. The tangential division from A to C. So, if I'm going to do that, I can have another, okay. So, ako na siya paano na, of course na, ng EI ha. Hindi ako namawala kay Bayang sa EI. So, ang positive na siya ay 6 times 720 times 2. That is 640 divided by 2. So, that is 4,320. So, ako isulat 4,320. 4,320. Okay, akong utuhon, 6 times 720 times 2 divided by 2, 4,320. How about ang isa? Okay, subo na to. 6 times 360 times 125 divided by 3. That is 1080. 1080. That is minus. So, 4,320. So, doon na sa 3 to 40. No? 3 to 40. Okay. 3 to 40. That is 3 to 40 over EI. The answer is positive, no? And because you will know only the sign here is meaningless. Okay. So, that means that this distance here, from this distance is TEC. It does not, so TEC nakuha na nimo, no? Okay. Nakuha na nimo. How are you going to determine the Y midspan? Of course, you are going to determine this distance, no? Kini siya nga distance, gikan dinhi, if I'm going to kini siya nga distance, sorry ba to? From this TEC, where you get the TEC, and then from this point, gikan diha, paingon diha, masolve ni mo na what is that distance. Okay, that is the slope of A times the radius, no? Because S equals to R theta, no? From your trigonometry, the arc is equals to R times theta, and R here happens to be 6, no? To be 6 times theta of A. Okay, times theta of A. Okay, so I will make that into this. So, ngana siya, no? Ngana siya. Ano nagamay ni? Substitute. So, okay, 6 theta A. So, from this equation, 6 theta A, okay, from that equation, kini siya din, ako nalabuton sa lecture ha, basta kini siya. So, I will just transfer it here. This is just my explanation. Okay. Anong una na ang X sub C, no? Ako lang to siyang mga, additional, okay? So, that is TEC. TEC is not what is being asked here. We are asked to determine the Y midspan. Yeah, ato yung determine TEC. So, this is what I'm telling you about kinina. You are not, it's not like equation nga, pag solve equation nila yun. It needs an analysis. So, TEC plus Y midspan is equal to 6 theta A. No? So, I will make that, no? It says here, from the diagram, okay, you'll see that from the diagram, yeah, that is not thus, Y midspan is equal to 6 theta A. So, TEC is equal to uh, 60 is equal to 60 A. Then we have minus minus I say y mid Spanish siya. Minus theta A is equals to y mid span. Y mid span. But we have theta A already, no? We have theta A previously. So we can see that this is equal to copy y mid span is equals to 6 times theta A. How much theta A that we get from the first problem? 1440 over EI. Okay, that's 1440 over EI times 6. So, I say this one is 1440 6 times 1440 over EI. Okay. Minus TEC, which is 3240 over EI. 3240 over EI. So here we have answer of is over EI. 6 times 1440, 6 times 1440, that's it, 640 minus 3240, 5400 over EI. Okay, that is the absolute value of the Y at mid span. Okay, that is the value here of the Y at mid span. PEC is only that much that we solved already, but we have solved already theta A, the slope of this one. The slope is in radian, so if you multiply that by radius, it will become the arc, which is 6 theta A. So here, from this analysis, no, Y mid span times PEC is equal to 6 theta A. So, mao niya akong basihan, kana. And then, akong gibali ng TEC sa PICAS, na din kada na. So, hard to, that is how it is done by moment area. So, i-check na to using formula. Check using formula. Okay. Now, I am going to determine the kuan. Mangita ko og kuan. Ang formula na ni apply sa y, no? Y is equals to 5W L to the fourth over 384 EI. Kung memorize man mo, sir, dugay, dito nagtudlo, no? So, wala siyang Y mid span. Basta, ito po may distributed load lang, no? Now, ini siya to the port na siya, din na siya times 4. So, for L equals to 12, for L equals to 12 meters, and W equals to 20 kilonewton per meter, negative. Kini siya, ibaw, ato nung ibaw dan nga down. Kaya balo naman sa daan nga down. Sa ito analysis down yung siya. So, kini siya, datawa ta kay balo nga down. So, ato we have to consider the sign of W. So, here, if you're calculating for the Y mid span, copy. I hope naman pala sila, no? Okay, ingano ba po nung mais na po ang kuhan. So, this is times 20. Ang L to the port actually becomes 12 divided to the port. So, you have 12 times 12 times 12 times 12, 12 times 12 times 12 times 12 is equals to 24,336. 24,336 divided by 384 ER. So, this is negative. Butang natin negative. So, over EI na siya. So, kato na siyang ikuan. Ikuan kaya ba sige sayot lugdan. Ikuan ba? Sulat. So, ang labas, this is different formula, no? I hope times 100 divided by 284. Takas sa 637.5 na. 12 times 12 times 12 times 12 2736 2736 na. 2736 times 100 divided by 384. 5400. Negative 5400 divided by EI. So, parehara sila. Parehara. No? No. So, kini siya, gamit lang formula, no? Gamit lang formula. Check using formula. Okay? But this one is, wiwitaan dyan na ito paagi, ngawa ta na gamit ang formula, no? So, medyo taas ang equation, ang iyang analysis mo, analyze pa mong ginta, no? Yeah, nagamit yung pag strategy, no? Kaya, kung kini imong gamiton, the problem is how to determine X sub C, no? Agos kung easy mo ma-determine X sub C, pwede ka mong gamit ang diagram, no? So, but I found it very somewhat not straightforward to determine X sub C in my case. So, I am going to break them down into simpler diagrams. So, yeah, we have a triangle and a triangle. We call these guys as a spandrel of a triangle. No? Spandrel. Okay. And considering the sign, the other one is positive, the other is negative. So that also appear in my equation. Okay. So, but that is just the tangential deviation. But using the considering our diagram as our guide, it will help us arrive into wide span. No? If we do some comparison of this line and this line. Okay. And then we arrive into an answer like equal to this, no? This one. That is our answer. And we check it using different approach by formula. This is equal, we arrive the same. Okay. So that means that our strategy and our solution is correct. We are already heading in the correct direction. Now, why I am teaching this to you? Because you need to have another method of determining. Do not just rely on one equation only. Equation is good only if the case of the load is found in the table. No. What about if the load is not there? So, wala kay mahimo. But if you have another way of solving it, no, solving it, you can still solve the problem. And besides, sa mga real nga problem, kining moment area method is applicable also, no, applicable. So, ang katong may formula, kung daghan kayo ng load, kadaghan sa kayo ka maggamit og case, no? So, but it will still arrive into the same. So, it's good that you will you have mga options, no? What method you are going to use. So, this afternoon I have actually discussed the concept of area moment in determining the depiction of a beam, no? So, ingon ana, I will upload the discussion that we have today in the e-learn, so that that will serve also as our note, and of course notes, and of course you don't have to stop there, no? So from this I am going to make an assignment. Okay, so I will assignment, so using the same figure. Okay. same figure sa may papadetermine, ha? The deflection. The deflection determine the deflection at x equals to 8 meters. Okay, 8 meters using the same figure. Okay, what so this one. Okay. So, maong gihapon. So, kini siya 20 km per meter ng gihapon. 20 km per meter. And this is A here. Tingin siya. A. So, ang C niya, din yung C. Ang C is na-adya sa. Okay. So it remains the deflection at point C. At point C. So x equals to 8 meters. Okay. Pi is constant. So use area moment meter. Okay, I'll teach you. What you will do here is that you move C here, no? C. So C will become A to C will become 8 meters. Also, this one will you move here. So there's a of point C. And then you can still use this concept, but C is here. So you need to yeah, you have already theta A, so you can determine this distance. And with the theta AC, so it's like that. So you can use the same, no? But C is here, no? So di nyo pang taon actually. Hindi ang C mo. Okay, wala sa tunga. Ha? So, mauna ang inyong assignment. So, na po yung assignment actually. Mauna siya. Okay. So, assignment next meeting. Mauna yun, no? Using the same figure lang yapon, no? Hindi siya 12 meters na yapon na siya. 12 meters. And C is here. 12 meters na yapon ang length niya. So, at point C, 8 meters, no? Using moment area method. Okay? So, ang metabuan niya, you can still use this diagram, but the weight will become somewhere here, bigger na, no? Bigger. And also, C, somewhere here. So, both your area, A to C, changes because the distance A to C is not 6 anymore, but 8. Also for the bottom, it's not 8. So, what happens is that the moment at C is different. Of course, it's negative, and the moment here is also not 720. And another thing that changes is the value of x sub c. Okay, you can use the same equation. Okay, and then you can also use the same diagram. It's not that. Use this diagram, but only move this to the other side. Okay, so this problem is solvable using the problem that we have, no? Only a little tricky because it moves to C. Okay, so I want you to submit this next meeting. Okay, So remember area, moment, method. This is not the same as equation. So kung kabalo mo sa equation, kabalo sa mong area moment, so mas daghan inyong naibaluhan. No? Mas daghan kaysa isa lang. Okay, class, I have to stop and say that this is all what this is all for today. No? So I hope you got what I am discussing. No? Ito naman siguro yung class. Okay, so any reaction?
Sir, so tulo ka assignment ipasa next week, sir.
Oh, tulo. Oh, pwede ko nyo nahuman ng wala pa rin nyo nahuman na natingog mo ninyo. So, it's actually a good exercise. So, especially that if you do it yourself, yung kwa, para makuha gini mo ang kuan by experience. So, lahat mo gini ng experience and the other one to lang mo nakita. Dahil kung ito yung nakikapan, yung mga natilawan, kana siya, imo ikaw din nagkuhan nagsulba na. No? So, kanang isulti man lang din mo, paminaw dali lang kana mawala sa imo nang una. No? Although maka-learn ka during the time you are listening, but after maybe few hours, mawala na to siya. Pero if you are really solving it, so medyo mudulot siya, dugay siya mawala. No? Mawala lang siya kung dili ni mo permanente practice. So that's the purpose why I give you assignment. I give you assignment, and also because your grade is dependent on your performance. So if you have grades there to be included in the calculation, so those grades actually are not just quizzes but also assignment. Okay. Any other? So, okay, I will upload this and then submit the assignment on the same page that I put it now. So, if you want to see the assignment, it's on the lecture that we had today. Okay, thank you, and so that's all.